Okay, let's do a question in cryptography. Okay, so let's call it question 3. So we have an operating system and there is something that is used to save password. I don't know, a file used, there is a file used to save password and we save the password accordingly. The password are saved like this. Every user pick a password k with 8 of 8 letters. Can be used for this. We can use this key for this. 8 letters. So the key for this should be 64, right? So 64 divided by 8 is 8. So each letter is a byte. I don't know, maybe. And then oh goodness. Okay, the system saved what? The following value, which is des of des. Oh, des. Okay, let's do it like this. Des k of des k of oh no, we need like this. Des k. You see that I'm using the same key one time after the other, and we continue like this until we are doing des of k of 0. And we are doing this 60 times. So here we have 60 times des after des of the des of the des with the same key, it seems. Okay, so okay, so you can see what happens. We are doing it 60 times, and when the user enter its user, so the key is the user password because the system encrypt 0 with the password 60 times. The system encrypt 0 and with the password 60 times. And then check if this encryption is in the file. And then check if the username and encrypted pass is in the text, in the file. The time it takes for one des equals t. Let's call, we have an effects where it is known for this question. Let's say assume the time, let's call it time for this encryption is the variable t. This is one assumption. All users can see this file. There are n users in the system. Now A We need to know the what are the disadvantages of the system. Maybe maybe two different keys can give the same password. Just think of it. Maybe I need to think about it. B, attacker wants to get into one of the accounts in the system and he has the file of passwords. We have file of passwords. Okay. Assume that all the password are different. What? It's like this. It seems, if I understand it correctly, that the attacker get the passwords file. All the passwords are different. How many times we should try until you will succeed? Now, I think that what it should remember that the file of password is like, I think it's like the ciphertext, because the system wants to get a password that the user insert, and then this result of all of this encryption is for each user is in the file. So what the attacker get, the passwords in the file are not the keys, but they are they are the ciphertext. They are the encryption after we did all of this, all the 60 this. And the third question is, we can change the encryption from 16 times of this to 600 times of this. Instead of doing this here 16 times as it's shown, let's do it 600 times and tell me what are the pros and cons of doing that. Okay, let's start. What are the disadvantages of this system? Maybe that we encrypt with the same key. A, disadvantages: we encrypt with the same key one after the other. Therefore, if I put many in the middle, what will happen? C equals E k of E k of P d k of C equals E k of P and dk on dk. Look at this. Use the same, exactly the same. The idea of meet beginner. So it's like an encryption of to this with the same key. So it's like only one time this. Not sure that I'm writing that right, the answer. This is ek, let's call it times 60 times 60. It's like a des 30 times with the same key. So it's like so we have in B we have n users all the passwords are different. How many tries should he do until he get one? So you need 2 to the power of 56 minus n. I think 2 to the power of 56 because this is the size of the key of this, and I explained why this function is like one this. Try because the keys publish this in the encryption same minus n because there are n different results that from them he needs just one. Therefore he needs 2 to the power of 6 minus n try. I'm not sure that I'm getting it right. Maybe I do a lot of mistakes. We can change the number of encryptions from 60 to 600. What are the advantages and disadvantages? If there are any advantages, it means that probably I was wrong in here. It's not like one. The same key. If I'm doing 30, that's with the same key. Wait. Doing twice this one after the other with the same key is like doing one time this in guarding the strength of the encryption. If you apply the DES algorithm twice in succession with the same key, it's effectively the same as performing a single DES operation. It has the complementation property, meaning that if you encrypt the plaintext block with a key and then encrypt the certain cipher with the same key, they usually cancel out and doesn't provide additional security. It's known as the middle attack. To enhance security, triple DES is often used, which involves binding 3 times with 2, 3. And if we apply 3 DES, but all with the same key, it's still like 1 DES. Exactly, if you're going to deal with use the same key for all 3 stages, it doesn't significantly security compared to single. The principle behind triple DES is to apply 3 different 2 or 3 different keys, different encryption methods. Prove that 3 DES with the same key is like 1 DES. Encrypt with triple DES generally works by applying the algorithm 3 times to the data. Normally you would have 3 different keys the process goes. However, when all keys are the same, it changes the security in the max. I mean encrypting 3 times. The answer is not full. I don't like the answer. Here is why. When you perform description 3 times in succession, where key is the key and P is the plaintext, the result does not enhance the security beyond a single des operation if the same key is used for each operation. In fact, no we shall give key length person is to achieve larger by using the same key. The effective length ability to prove uh, or it won't prove that 3 des with the same key is equivalent to 1 des. Why decryption? Why it's to decryption? When we use the 3 des with the same key for each encryption and decryption step, it looks like this. In 3 des aren't we doing encryption 3 times? Why did you do encryption? And if we do 3 consecutive encryptions, one after the other, but with the same key, it is still like one, like doing one this. No, if you perform 3 consecutive this with the same key for each step, it's technically not identical to a single encryption, but it still does not add any meaningful security compared to single des. Here's why. Compared to encrypting 3 times in a row with the same key, the operation looks like this. In this case, the repeated encryption does not result in different ciphertexts that if you would apply just one encryption. However, this approach does not. In this case, the repeated encryption does result in different ciphertext than if you apply just one test encryption. However, this approach does not significantly increase the security, and here is why. While communication with the same key is not secure, no increase in key space. Even though you are applying encryption 3 times, you are using the same 56-bit. This does not increase the efficacy of length. Attacker can still attempt to break the encryption using only a single key, as it is where one wrong key. This is vulnerable to various cryptographic attacks, such as brute force attacks and medium attacks. To its applying 3 consecutive des encryption with the same key does not prevent these types of attacks because attackers only need to discover the single key, not a sequence of multiple keys. Theoretical redundancy and repeated encryption. Growing repeated implication of the same transformation with the same key do not meaningfully increase security because the underlying key and block cipher operation remain identical. This means that, although the result is not exactly the same single decryption, the repeated encryption process does not improve resistance to cryptanalysis. component CD mode different when standard encryption sequence in different keys designed specifically to increase the effective key space, preventing key vulnerability by using existing keys and each set. Thus, without different keys, simply repeating encryption multiple times with the same key does not provide the security benefit that readers was intended to achieve. So, a three consecutive encryption with the same key result in different ciphertext. Then, a single desk encryption it does not add any meaningful security beyond single desk. It still suffers from the same vulnerability and does not increase the effective key space. So, the result and the let's say the conclusion is that it's not really changing. It's not changing the space of the key. You still have the space is still in the same size, 2 to the power of 56. The disadvantages now the question is if we change and instead of doing 60 encryptions we do 600 encryptions. What are the disadvantages and what are the advantages? Now the disadvantages more time is this of I don't know key equals let's call it time this equals t. So instead of 60t time we now have 600t time. Advantages: there are no real advantages in my opinion, as we do this with the same key each time. The space of keys is still 2 to the power of 56. Therefore, it is not making the security any better. So I don't think it's make any good. So this was this question. I probably did mistakes, yet thank you. This is just me trying to solve a question. Maybe I did a lot of mistakes. I'm sorry. This is just again me trying to solve. This is not a solution. This is not I don't know what. So let's see just for a sec. Okay, this was okay. Thank you very much. If there are mistakes or corrections, probably there are. That's it.